So how can a nonpolar substance contain polar bonds? To begin answering this question, we first need to know what a nonpolar molecule is. So, a nonpolar molecule is a substance in which all of the electrons are arranged in such a way that they are distributed symmetrically and equally, which means that both ends of the bond will have the same charge. For example, in diatomic molecules, such as Cl2 or O2, these are nonpolar molecules because not only are they symmetrical, which is a requirement for the majority of nonpolar molecules, but they also have two of the same atoms, which means that they have the same electronegativity levels. Alright, so that can work in any symmetrical molecule, even tetrahedrals or octahedrals. So the other thing we gotta learn about are polar bonds. Alright, so polar bond is any bond in which there is an unequal sharing of electrons around the molecule. So that happens in cases such as these. So you can see we've got water on the left, and you can see that it has a negative dipole up here and a positive here, because we've got these lone pairs of electrons on the top of the oxygen atom. And you can see the same on this NH3 here. You got positive dipoles on each of the hydrogen. You can kind of cut it in half and see that you've got a positive end down here and a negative end up here. Alright, so then we can see that polar bonds in nonpolar molecules are possible because of symmetry. So what happens is you get molecules such as this. So this is carbon disulfide, and the reason why it is nonpolar is because you can divide the atom or the molecule in half right at the C, and you can see that both ends will then have the same charge, and they'll cancel each other out, which means that the atom has no dipoles. You can also see that in bigger molecules like this. So PCl5, you can see that each end is evenly spaced and they all have equally distributed electrons, and this is a nonpolar molecule. And then it happens in even really simple cases such as this, CO2. It's nonpolar because both of the bonds would create negative ends on the oxygen, but they just end up canceling out and it becomes symmetrical, so it's nonpolar.